Good evening. Today in class we did 1 to 5, 8 to 13, 6 to 22 even, 44 and 45. That's all from page 351. So if you didn't get that done in class, you need to do that tonight for homework as well. Tonight's evening talks about the Pythagorean theorem. So Pythagorean theorem. We're going to utilize both the legs and the hypotenuse, to solve for Pythagorean theorem. So the legs are the sides, and the hypotenuse, I've been calling it the slant. So the hypotenuse is the slant. Let's write down the main definitions. Alright, and just to go over the objective for today, the objective for tonight is the student will be able to use the Pythagorean theorem, the student will be able to use the converse, so the opposite of the Pythagorean theorem. So we have legs, I've labeled them A and B, the two sides that form the right angle, you should be writing this down, and C is the slant, also known as the hypotenuse. So the side across from the right angle, so right angle or the 90-degree angle that we see in the corner of A and B. The longest side is C, the hypotenuse. So now what is the Pythagorean theorem? Well, the Pythagorean theorem, Pythagoras made up, he says the sum of the legs squared equals the hypotenuse squared. Take some time and write this down. Alright, before I show you exactly how it works, I want to tell you some perfect Pythagorean theorem problems. So these are going to be called Pythagorean triples. So if I have non-zero whole numbers for which a squared plus b squared equals c squared, I would have these four. There's more, but they're much larger, so we'll focus on these four for a second. Alright, so with 3, 4, and 5, I could prove a squared plus b squared equals c squared, because c is always going to be the larger number, so the 5 is the c. So 3 squared plus 4 squared equals 5 squared. Let's make sure it's a Pythagorean triple. Well, 3 times 3 is 9, 4 times 4 is 16, 3 plus 9 is 25, and 5 times 5 is 25, so it checks. Let's try, I'm going to tell you this one works. Let's see if this one works. 7 times 7 is 49. 24 times 24 is 576. 576 plus 49 is 625. And if I took the square root of 625, you would get 25, because 25 times 25 is 625. Alright, now we're going to try to solve one. So we have two sides. This is side A or B, doesn't matter. And this is side B or A, doesn't matter, but I labeled them A and B. I know that it's not C, because C is the hypotenuse, the longest side. So it says, do the lengths of the sides form a Pythagorean triple? So let's find out. So I could do 21 squared plus 20 squared equals blank. So let's solve that. 21 squared is 441, 20 squared is 400, then I add those two together and I get 841. So it will be a Pythagorean triple if it comes out to be a perfect number. So if I take the square root of 841, I would get 29. So my side C, or length AB, is 29. So since it's a perfect number, yes, it is a Pythagorean triple. So if you want to add that to your list up here, you could call 20, 21, 29 a Pythagorean triple. Alright, let's look at problem B. A right triangle has a hypotenuse, so the long edge is going to be 25 centimeters. and one of the legs is going to be 10 centimeters, and we need to find the third side. So we need to discover x squared plus 10 squared, which is 100, equals 25 squared, and we did that earlier and got 625. So 25 squared is 625, and then 10 squared is 100. So 625 minus 100 is 525, and I would take the square root of 525 to get x. So I'm going to let you solve B for homework, as well as I want you to do for homework example 2, A, B, and C. So the hypotenuse is the long piece across from the right angle. So that's C. So I would do 20 squared, which is 400, equals 8 squared, which is 64, plus what equals 400. So something plus 64 equals 400. Well, 400 minus 64 is 336. So I know x squared is 336. And then to find x, I would take the square root. The square root of 336 is 18.33030278. So we're going to go ahead and round to the 10th. So 18.3. So x is going to be about 18.3. You can always kind of check yourself, make sure that the side, since this is a side that we're solving for, is smaller than the slant. And it says leave your answer in simple radical form. I'm sorry, so we're actually not going to do the tenths. We want the simple radical. So take 336. That's why we've been practicing radicals. And I want you to simplify that, so I can look at 336 and say, what goes in? And let's see here. I think 4 is going to go in. Yes, so you could split that up into the square root of 4 and the square root of 84, and then I think 4 is going to go in again, so keep going until you get a simplified radical. I want you to also try example 3. We will fill in these theorems tomorrow and talk about 4 and 5 in class. Have a good night and good luck.